Immersive analytics focuses on engagement and immersion for data understanding and analysis. It has the potential to reduce barriers between people, data, and tools. It can leverage human abilities of perception, cognition, and interaction to explore and comprehend complex data with increased engagement, motivation, and insight generation. I am interested in its novel ways of interactions with data, and particularly the multimodal aspect of them to create accessible and engaging content. The three papers I selected are all related to this theme, but each of them focuses on a different aspect of it. The first paper by Tom et al. Presents a design space of techniques to interact with paper visualizations with augmented reality. The second, by Ganku et al., explores the use of audio and haptics to interact with information graphics. The third, by Patnick et al., focuses on the use of scent as a modality to convey data. Tom et al.'s paper presents an innovative application of immersive analytics, which digitally augments physical media. The study explores the combination of physical affordances with digital augmentation through augmented reality. The authors propose a design space that investigates how physical interactions can be integrated with AR to create immersive and novel data exploration methods. They also conducted a user study to assess the usability and user preferences of these techniques. The prototype developed by the author supports 11 interactions, mapping paper actions to visualization commands like fold to zoom and collate to link. These interactions are categorized in a design space based on command, degree of information, and number of sheets. The user study evaluated participants' preferences for these interactions using 4 metrics. It was found that participants favored point-based gestures and spatial paper actions like tilting over folding. Despite its comprehensive exploration of paper interactions for AR and its user-centered design approach, the paper does not discuss the system's scalability. It does touch upon potential applications of the proposed techniques, but a comparison with other interaction modalities, like mid-air gestures, could further enrich the study. Vision is an important sense for quickly exploring the environment, but immersive analytics is not just about visualization. Often, other modalities are overlooked. The Gravatar system was provided by Ganku et al. As an example in the position paper on immersive analytics by Chandler et al., and it proposes ways to engage with information through audio and haptic with touch interactions. It presents the design and evaluation of the system, which is built using a tablet, vibrating motors attached to the fingers, and headphones. When a user's finger touches a graphical element, they receive vibrotactile feedback and a sound that indicates the type of the element. For query, the user can double tap on an element to hear more detailed information, and for overview, the user can perform a 2-finger swipe gesture to hear a summary of the graphics. The paper also studies the usability and effectiveness of the tool by conducting several user evaluations with different kinds of information charts, such as tables and floor plans. Participants were asked to explore them freely and answer questions, and they could provide mostly correct responses without visual stimuli. The paper addresses an important and challenging problem with data analytics without the reliance on visuals, adopts a user-centered design approach involving the end users, and evaluates the tool with a variety of use cases, providing validity and generalizability. However, it does not compare with other existing techniques, such as tactile graphics or audio description, nor discuss the scalability for complex information. The tasks involved in the studies are also fairly simple, but the paper certainly provides a good starting point for future research. Patnick et al. Explores another interesting non-visual sensory channel, scent, to provide alternative or additional information for analytics. The paper proposes a design space for information affectation and presents a prototype system called vScent demonstrated with 3 use cases. The design space is based on olfactory marks such as fragrance, bouquet, and airbursts, and their olfactory channels such as intensity, direction, temperature, and frequency. The paper proposes the potential tasks and benefits of information affectation, such as information recall and feature detection. The prototype vScent is a 6-cent stereo olfactory display with controls of temperature and direction of scent, and is demonstrated with 2D graph, line chart, and 3D analytics graph. The paper introduces a proactive and unconventional way of representing data and provides a theoretical framework based on previous empirical research on affectation and visualization. However, the paper does not include user study to evaluate the effectiveness and usefulness of vScent, making its claim a bit speculative. It also does not discuss the scalability of the system, and the use cases are fairly simple. In summary, all three papers explore novel ways of using multi-sensory modalities for immersive analytics. Paper interactions with AR can leverage tangible affordances and tactile modality of paper and dynamic capabilities of AR to create rich and playful ways of manipulating data visualizations printed on paper sheets. Furthermore, audio, haptics, and scent can complement visual modality to convey data attributes, patterns, or insights, and can support information accessibility. They all provide empirical grounding behind their design and prototype systems, which demonstrate the use cases and potential applications of immersive analytics.